This is Nikhil Naka. Follow me on Unacademy Learning app for more awesome videos for your electrical engineering exams preparation, GATE or IES. So in this lesson, we will start discussing about problems about Y-bus matrix. So far we have discussed how to form a Y-bus matrix and how it is useful to us. Now let us discuss or enhance our understanding by discussing some important problems. Let's begin. So the first problem. Now you see here there are three buses, bus 0, bus 1 and bus 2, and these buses are connected by three transmission lines like this, and each transmission line has admittance like this. Y01 means admittance between 0 and 1 as plus 1 plus J2, and here Y12 2 plus J1, Y02 3 plus J3. So here three buses are there, therefore 3 by 3 matrix is going to be our the matrix. So 3 by 3 matrix, 0, 1 and 2 are the buses. So Y00, Y01, Y02, Y10, Y11, Y12, so on. This is going to be your matrix. Now what is Y00? Y00 is the sum of all admittances connected at bus 0. So what are the all admittances connected at bus 0? Y01 and Y02, isn't it? Anything else is there? Only these two are connected. So sum of all of them. That is going to be a Y00. Similarly, Y01. And Y01 is going to be equal to Y10. That is equal to minus Y10. So minus of 1 plus J2. Similarly, Y02 will be equal to Y20. That is equal to minus Y202. That is also minus of 3 plus J3. Y11 is the total admittances connected at bus 1. So total admittance at bus 1 means what are the admittances connected at bus 1? This and this, right? Y01 and Y12. So sum of them, this is plus, it should be plus here, 3 plus J3. Similarly, Y12 will be equal to Y21, mutual admittances, minus Y12. That will be minus of 2 plus J1. Y22 is the self-admittance matrix, self-admittance of second bus. That will be equal to the total admittances connected at second bus, Y20 plus Y12. So adding them, you get this as a value. So finally the answer is going to be this matrix. Let's do the next question. In this question, the impedances are given in per unit. Okay, find the Y-bus matrix. See, there are three buses, bus 1 and bus 2 are nodes, bus 2 and bus 3 or node 3. Nothing is mentioned here, though, so this should be the reference bus. Okay, that is nothing but ground. So he's given the Y10, isn't it? Y10. What is Y10? J1. Although J is not mentioned, it is impedance. Okay, you take it J1. So impedance, so one thing is there. So impedance means Rj plus X, R plus Jx, isn't it? Z is equal to R plus Jx. So usually we don't consider the R. Most of the analysis of power system, we will be neglecting the R to ease our calculations and make the calculations simple for simpler understanding. So you also follow this convection. So Z is equal to J1, neglecting the resistance because it is the conventional practice. So the admittance of this element is going to be Y10, that is equal to 1 by Z10 minus J0.1 is going to be the admittance. Similarly, J30, okay, the element between 3 and ground. So J2 is given is Z, okay, Z30. So the admittance of this element is going to be Y30 is equal to 1 by Z30. Please correct, this is Z30. That is equal to 1 by J2. That will be minus J0.5. Z23 impedance between 2 and 3, J3 is given. 1 by J23 is Y23, that is equal to 1 by J by 3, that is equal to J0.33, isn't it? This is a 3-bus matrix. So 3-bus matrix means you will have diagonal elements and off diagonal elements like this, Y11, Y22, Y33. Similarly, off diagonal elements are Y12, that will be equal to Y21, Y13 equal to Y31, Y32 equal to Y23. Y11 is the total admittance connected to bus 1. So what is the total admittance connected to bus 1? Only one branch is connected to bus 1. So this one only. So minus J0.1 is going to be the Y11. So Y22 is the total to to the bus 2. So what is the total connected to bus 2? Only this branch is connected. So you can say j minus j 0.33 is going to be your y22. Y33 means total elements or total admittance is connected to bus 3. To the third bus, this element and this element both are connected. So I can say y30 plus y23. So minus j 0.5 plus minus j 0.33. So j minus j 0.833. y12 equal to y21. That we know, but what is the value? 1 to 2. There is no active connection between 1 and 2 bus or 1 and 2 nodes. So that is 0. y13 is equal to y31. So 1 to 3. So 1 to 3 also there is no connection, direct connection. So that is also 0. y32 will be equal to y23. 3 to 2, 2 to 3 there is a connection. That is minus j 0.33. Okay. So minus of minus j 0.33. y32 or y23 will be equal to minus y23. Please keep this in mind. Off diagonal elements are negative of the original admittances, whereas the self or the diagonal elements or self admittances are sum of the original admittances. Okay, there you will get the answer in negative self admittances or the diagonal elements, but off diagonal elements will be positive because they are negative of the original admittances. Original admittance is always in negative. So this is going to be your y bus. There is another question here. There is a bus 1 and bus 2 is there. Okay. 0 is the reference bus because he is taking the voltage between 1 and 0, 2 and 0. So V1 is the voltage between 1 and 0, V2 is the voltage between 2 and 0, where 0 is the reference bus. It is a 2 by 2 matrix, y11, y12, y21, y22. So y11 will be equal to y21, that is equal to minus of y12, means negative of the original admittance. What is the original admittance? Minus y12. 122 is j 0.75. So minus of j 0.75 will be j 0.75. So y11 is the total admittance connected at bus 1. So these two are connected. These two elements are connected to 1. So y12 plus y10, isn't it? This is y10 and this is y12. So sum of them will be minus j 1.2. Similarly, y22 is the total connected to second bus. What is the total elements connected to second bus? To the second one, y20 is connected, this one, and 2 to 1 also there is one connection. So y12 plus y20, sum of them you will get minus j 1.35. So the matrix is going to look like this. So you look at the matrix. So finally you are getting the answer. The diagonal elements or the self admittances are negative values, whereas the off diagonal elements you are getting as the positive values. Why is it like that? Because the off diagonal elements are the negative of the original admittances, and obviously the original admittance will be negative only. What is the reason? For example, see, for an inductive, basically the transmission line is an inductive. So inductive reactance will be j 0.5, isn't it? Inductive reactance is j 0.5. It will be positive, j. So I am finding the admittance of that inductive reactance. So 1 by z, that will become minus j2, isn't it? Now you are getting minus because the element is an inductor. The admittance of inductor is going to be a negative. So minus j. So that is the reason why originally the admittance is negative here. Therefore, when you are taking negative of negative, it becomes positive. So off diagonal elements will be positive and diagonal elements will be directly the sum of original admittances. So obviously you will be getting the answer in negative only. So please keep this in mind. Okay, off diagonal elements will get in negative, whereas this will be in the positive. Okay, hope you enjoyed this lesson. In upcoming lessons, I will upload more problems regarding Y bus and we will discuss a little bit more about Y bus. Thank you.